Today we're going to talk about the law of cosines. The law of cosines is similar to the law of sines in that you use it to find missing sides or angles in non-right triangles. But the law of cosines should be used in side, 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 and side angle side cases. So in cases where you know all three sides at the beginning of the problem, or in cases where you know two sides and you know the angle in between. That would be a side angle side case. So those are when you would want to use the law of cosine. Now the law of cosine looks like this. So you can see it's a side squared equals the other two sides squared minus 2 times each of the sides times then the cosine of the angle across from the side that you're trying to find. So when we are solving these triangles, in order to avoid possible side-side angle cases, you're going to want to use the same law that you start with to complete the entire triangle. So in a problem where you start with law of cosine, you're going to want to work through the whole problem using law of cosine. In a problem where you start using law of sine, you're going to want to work through the whole problem using law of sine. So let's just go ahead and get started. So in number 1 and number 2, it asks us to find the value of x. So this right here we can see is a side angle side case. So we're going to use the law of cosine. We're looking for this side and it's across from this angle. So we're going to have x squared equals, and then we do the other two sides squared minus 2 times each of those other two sides times the cosine of the angle that's across from the side we're looking for. So here that's 40. So then, if we simplify that, 7.3 squared, you guys are going to want your calculators for these, that'd be 53.29, and then 11.5 squared, that is 132.25, and then minus 2 times 7.3 times 11.5, that gives us 167.9 times the cosine of 40, and then adding our like terms here, that gives us a 185.54 minus 167.9 times the cosine of 40, and then we would just want to figure out exactly what that right hand side is equal to. So x squared is equal to, it's about 56.92, and so then when we square root both sides to find x, we get that x is about 7.5 centimeters. Okay, and if we look at number 2, same type of idea. We're looking for this side here, but now the angle that it's across from is 140 degrees. So again, we'd have x squared equals 7.3 squared plus 11.5 squared minus 2 times 7.3 times 11.5, cosine of, now the angle is 140, and just like we have above, that's going to simplify to the same as this line, but cosine of 140 instead. So 185.54 minus 167.9 times the cosine of 140. And when we put that into the calculator, we get then that x squared is about 314.16. And then when we square root to find what x is, we get that x is about 17.7 centimeters. So that's what we do if we're trying to find a side. Now, if we look at number 3, it says to find all of the angles in the triangle given the side measurements. So first thing that we would want to do is draw out a picture. So here's A, B, C. Side A is 33, side B is 7, and side C is 37. So you just pick whichever angle you want to start with. So I'm going to say let's start by trying to find angle A. So we would have side A squared equals the other two sides squared minus 2 times the other two sides times the cosine of that angle, but we don't know what the angle is, so we're just going to write capital A. So then we have 1089 is 33 squared, 49 is 7 squared, and then 1369 is 37 squared, minus, and then 2 times 7 times 37 is 518. So then here's where we have to be a little bit careful. So you are going to want to subtract the 49 and the 1369 from both sides, because you are trying to get that cosine A by itself. You cannot combine those with that negative 518. So when we subtract both of those values over, we get negative 329 is equal to negative 518 cosine of A. So then when we divide by that negative 518, we find that the cosine of A is equal to 329 over 518. And so then we have to do the arc cosine of both sides. Remember, arc cosine is the cosine with that little negative 1 next to it. So that gives us that the measure of angle A is about 50.6 degrees. Make sure when you're doing this that you are in degrees when your angles are given in degrees, right? If your angles are given in radians, you would want to make sure that you're in radians. So we found one angle, 50.6 degrees for angle A. So now we're going to have to do the same thing, but we need to find another angle. You could find B or C next. I'll say let's find B next. So we have 7 squared equals 33 squared plus 37 squared minus 2 times 33 times 37 times, then it'd be the cosine of angle B. So that's 49 equals 1089 plus 1369, and then minus 244 2 cosine B. And then just like we did before, you have to actually subtract both of these two values, the 1089 and the 1369. So then that gives you negative 2,409 is equal to the negative 2,442 cosine B. And then when you divide, you see cosine is equal to 2409 over 2442. And then again, doing the arc cosine to both sides, we now get angle B is equal to, it's about 9.4 degrees. So we've got two of our angles. And so now you could use law of cosine to find that third angle, but remember that the angles in a triangle have to add up to 180 degrees. So if we do 180 degrees minus the 50.6 minus the 9.4, that will give us the measure of angle C. So angle C here would be, when we subtract those, that ends up giving us right about 120 degrees. So we have found all three of the missing angles. For the next problem, it says a regular pentagon is inscribed in a circle of radius 1 unit. Find the perimeter of the pentagon. It says, hint, first find the length of a side using law of cosines. So I have a circle, and then a pentagon has 5 sides. So I'm going to put 5 points on my circle and draw in my pentagon. And then it says that the radius of the circle is 1 unit. So if my center is here, and I draw in these radii, those each have 1 unit. And then if I want to figure out what this angle is, remember that I could think of this as 5 triangles, each with the same angle in the center, and all of those angles in the center would have to add up to 360 degrees. And there's 5 of those triangles. So 360 degrees divided by 5 means that each of those angles is 72 degrees. So if I want to find this side, then I can use the law of cosine. So x squared is equal to the other 2 sides squared minus 2 times each of the other sides times the cosine of the angle across from the side that I'm looking for, so 72. So then I have x squared equals, it'll be 1 plus 1 minus 2 times the cosine of 72. So x squared is equal to 2 minus 2 cosine 72. And if we put that into the calculator, we see then that x squared is equal to, it's about 1.382. And when we square root it, we get that x is about 1.18. And again, we don't want to use any rounded answers here, so make sure you're keeping the exact answer on your screen, because we're looking for the perimeter of the pentagon, and the perimeter of the pentagon is equal to 5 of those x's. So the perimeter is 5x, and that means that would be 5 times 1.18, so the perimeter is 5.9. Okay, and then the last problem that we're going to look at talks about bearing. So it says town B is 26 miles from town A at a bearing of south 15 degrees west. So whenever we see these bearing type problems, what we're going to do is we're going to draw out kind of almost like a compass. So you see north, east, south, and west. So southwest would mean that you're somewhere over here in quadrant 3. southeast would mean that you're somewhere over here in quadrant 4. Northeast would be quadrant 1, northwest would be quadrant 2. Because both towns B and C are being described as being away from town A, I'm going to put town A at the center here at the origin. So there's town A. Town B is 26 miles from it at a bearing of south, 15 degrees west. So it's over here, and it's a 15-degree angle away from south, going towards the west. And that's a 26-mile distance to town B. Town C is 54 miles from town A at a bearing of south 7 degrees east. So that would be over here. Here's town C, 7 degrees closer to east from south, and that measurement is 54 miles. Now it's asking you to compute the distance from town B to town C. So from B to C, that's this measurement here. That's what we're looking for. So this is a law of cosine problem. So if we just kind of look at what that triangle looks like here, A, B, C, we know that this side is 26 miles, this side is 54 miles. We're looking for this side, and we know that this top angle up here is 15 plus 7 degrees. So that would be 22 degrees. So now I can use the law of cosine to find that missing side. So I would have x squared is equal to 26 squared plus 54 squared minus 2 times 26 times 54 times the cosine of 22. So 26 squared is 676 plus 54 squared, which is 2,916, minus 2 times 26 times 54 is 2,808, times the cosine of 22. And then combining our like terms, that gives us 3,592 minus 2,808 cosine 22. And then simplifying that right-hand side, figuring out what that is, that gives us about 988.5. So then when we square root and find that missing side, we find that the distance between those two towns, rounded to the nearest mile, is 31 miles.